I'll pass around this. Looks like a young pigeon, and you can see where the feathers are coming in. Very obviously, they're coming in specific locations in specific feather tracks rather than across the entire body. Okay. Feather color. You can get color in two different ways in the feathers of birds by use of chemicals or what's called structural color. Your chemicals are two broad categories. You have carotenoids and melanins. So different molecules, and they're going to give you different colors. So the carotenoids gives you your reds, yellows, oranges. So think of a carrot. So particular molecules, they're pigments. When present, they're going to give you a red, orange, or yellow color, depending exactly on which carotenoid molecule you have and how much of it. That will determine on the shade of red, orange, yellow, and the brightness of that red, orange, yellow. Melanins are going to give you the dull earth tones, so black, brown, brownish yellow. So when you see something like a cardinal, the primary pigment, primary molecule that's in the feathers of that animal is carotenoids, giving you that red color. You see something like a red-winged blackbird or an ugly starling or most of the body of a grackle. Those feathers have primarily melanins in them that are giving you these darker colors, the black, brown, brownish yellows. Structural color. You get different colors based upon differential absorption, scattering, or interference of light waves. So it depends upon the surface, the microscopic surface structure of the feather. Depending on that surface, you can allow some light waves to come through and be absorbed, others will be reflected. You may scatter the light waves differentially, or you may have interference. Go back to physics, interference of light waves. But the upshot is there's no chemical, there's no pigment that is in there that is giving you that color. It's simply a result of the interaction between the light rays and the molecules that are forming the structure of the feather. These often are the source. In other words, structural color is usually what provides your blues, bright blues, bright greens. Those are very often structural. Feathers that have a metallic quality to their color. Also, that metallic color usually results because of the structure of the feather and not a pigment. And I think I mentioned it to somebody in here. There's a classic little demonstration you can do. You can go get a blue jay's feather, bright blue animal. You can put that feather into a mortar and pestle and you can grind up that feather. And when you grind it up, it is no longer blue. You have a white powder. And that's because the blue was being caused by the structure of the feather, the surface structure. You destroyed that structure when you ground it up in the mortar and pestle. so you no longer have a blue feather. You can put the red feather from a cardinal into a mortar and pestle and grind it up, and you'll have a red powder, because the red is due not to structural color, but to actual chemicals in the feather. All right. Okay, molting, losing feathers. Well, all birds are going to molt. All birds are going to replace most, if not all, their feathers at some point, usually once per year. Okay, powder down would be the exception here on feathers, because powder down is not molted. Most birds do it once per year. Take mammalogy and you'll see mammals often will do it 2 times a year. All right, so birds do it once per year. It's usually after the reproductive season, so after the young have fledged and are out on their own. And it takes a few weeks to a few months to replace all those feathers. Most of them then are doing it just a few feathers at a time. Right? You don't see too many naked birds running around out there in the wild. Right? They get cold. So molting is a long process because they're not changing all the feathers at once. Instead, it's a few at a time. The pattern of molting, the pattern as to which feathers are being lost, is definite. In other words, there's a definite pattern that is followed. It's not random. Right? That pattern will differ among different birds, especially in different orders. But take passerines, for example, Passeriformes. If you look at their wing feathers, their primaries are going to be the first ones. And they're going to go from the wrist outwards. In other words, the first primary that is molted is the one that is closest to the wrist. The last one would be the most distal, the farthest away from the wrist. The secondaries, though, are lost in the opposite manner. They're going to be lost, well, from near the wrist first, but then go inwards. So the most proximal is the last one to be lost. And then the tertiaries are reversing again, and it's the ones near the shoulder that are lost first, and then progressively outwards. Okay? I'm not going to ask you to remember that. It's just an example of there being a distinct pattern in molting among birds. Yeah, that's passerines. Just for a difference, ducks and geese lose all of their primaries at once. Instead of going from the wrist outwards in a slow process, they lose all of theirs at once. So that makes them flightless. Why aren't they eaten all the time? Well, there's always something that's going to be willing to eat them.
Is it oily?
No. It's more the idea that the ducks and geese can be out in the water. And so unless you're in an area where your predator is coming up from underneath, you're fairly free of predators. So they can escape predators by staying out on the water. Some things will come up and get them if they're in the wrong place, like an alligator. All right, one last thing that's sort of associated with feathers, and that is skin glands. You know, we talked about amphibians having lots of skin glands. Reptiles then had hardly any, and they were primarily for creating chemicals for communication, pheromones. There's generally no glands in birds either. One exception, though, is the uropygial gland. And it's usually well developed in birds, particularly in water birds. Okay, where do you find it? Well, So, at the base of the tail, but in front of that base. Dorsal surface of the bird in front of the tail is where you find the uropygial gland. Most of you at some time have probably fed ducks someplace. You know, you throw bread into the water and they're all attacking it and everything. But if you watch the birds when they're not feeding, you'll very often see that bird turn around and nuzzle the base of his tail or her tail. That gland is producing an oil that the bird then will spread all over its bill and then eventually to all of its feathers. The function of that oil is similar to the oils in your skin. One, it's going to keep the feathers supple. Two, it's going to keep the bill in good shape, not cracking. And a third thing is that it can be important in waterproofing and buoyancy. And of course, especially in the water birds in which this gland is very well developed. Okay? Most of them have a uropygial gland because most of them need to keep their feathers supple and most need to keep the bill from cracking. But in the water birds, like ducks and geese, you're going to find it very well developed because it will help waterproof the feathers. That will make the animal more buoyant because the water is not penetrating to the skin of the animal. I'll pass this around. It's just a cute little photograph. Oh, maybe I could do this. Can I do this? Won't get any brighter, I guess. These are just two birds, obviously, Anseriformes. One was not treated in any way. The other one was treated with a chemical that removed the oil from its feathers. And I think you can tell which one had the oil removed. So this one is no longer as buoyant as its friend over here because that water is now penetrating through the feathers and replacing the air that used to be there. It's the air that gave this one a lower density, so it floats better. This one doesn't float as well because its density is increased because the water has penetrated and replaced the air in that. That's better. Okay, enough of feathers. Next time we'll talk about other structures in birds, and then we'll get into stuff concerning powered flight, aerodynamics, soaring, gliding, fun stuff like that. I went through the birds last week, and I do have a problem in that some of these have disappeared. So I do not have out examples of the junco, number 25 on page 31. I'll let you guys find photographs online. Junco. Chipping sparrow and song sparrow, 39 and 40. And very surprising to me, number 1 and number 2. I'm just surprised. I don't know how they disappeared. So mallards and blue-winged teal are not out either. Every other Michigan species is there except 14, which it tells you there is no specimen. Most Michigan specimens are over on these shelves, although the turkey vulture, the eagle, I'm not sure if anybody else is over there, right? Because they're big. So we're going to have the lab exam on birds in 1 week. It will go over the taxonomy, anything that's in the course pack, the outlines of birds, and bird songs. Okay. All right. And then on Wednesday, I'll try to have some slideshow review